This is the sixth lecture on our human and environment interaction in Discovered Geography. And in this brief lecture, what I want to talk about is the idea of humans within an ecosystem and within the biosphere, and in fact, the ecosystems as models of what we would call sustainability. And it's important to understand when we say this idea of sustainability, we understand ecosystems as interactions of communities of organisms and their environment. We understand the biosphere is the largest way of understanding this in the sense that it is the living sphere of our planet. But when we say sustainable, what we mean by that is a system that, while it may vary or modulate in terms of certain factors, essentially continues to function in a continuous way without degradation for a period of time. Now, all systems change over time. That's certainly the nature of life on this planet is change. But we understand that these systems allow us to understand how inputs, throughputs, and outputs can be understood. So if we look at this, what I want to do is put some things in context. So when we think about the world's oceans, this is one of the major ecosystems, macro ecosystems of the planet. And what you're seeing here is a petri dish that contains what we would call the microplastics that were sampled out of the Pacific gyre, the area of the Pacific Ocean where circular currents accumulate material. And what we're beginning to see is that human materials are ending up everywhere in our Earth systems. And that this idea of waste and very commoner's idea of there is no way is becoming more and more apparent. So if we think about this, this is an image that was recently published in the New York Times regarding the island of St. John. And due to the virus and the pandemic, many of the bare boat, the sailboats that are flagged as American have been forced to return to a relatively small island that is a U.S. territory. As a result, these boats are putting their trash on the island. And this very small island is having to deal with this idea of there is no way. So much of this material on such a small area is stressing the sustainability, the ability for this island to persist in its current state. Now, what we can see is this is true throughout many of the smaller islands, and they use islands as systems that we can understand because their size is so small. What you see here is a beach on San Salvador Island in the Bahamas, and to the east of this island, this is the farthest east island of the Bahamian chain, and really there's nothing between it and the coast of Africa. And yet, the amount of trash, the amount of plastics that wash up on the shore every day is really astounding. I used to take students here, and they were always amazed that an island that in some respects was so pristine became so contaminated with the world's plastics. And this makes the point of there is no way, and that ecosystems, in a sense, as models, work under this premise that nothing disappears. It is recycled, it is changed, but it continues to exist within the system, and that all organisms have to deal with their own waste and consumption. So when we think about this, that today we often hear the ideas of what we call these garbage patches. These are these gyres, these circulation patterns in the Pacific Ocean most notably, where because of the circulation, the waste gets concentrated. And it allows us to see that we are producing this type of concentration of our waste, and that we don't think about what happens to our materials after we no longer use them. Now, what that results in are some pretty dire scenarios. This happens to be an albatross that on far out in the Marshall Islands was photographed. And what happens here, albatross is a skimming feeder, and so as it goes down to catch small fish near the surface, it often will also ingest pieces of plastic that are floating near the surface. And unfortunately, these materials can't pass through the digestive system of the bird, and eventually it dies from that. And again, this suggests this issue of the system understands, if you will, that there is no way, that everything that we produce becomes part of the system that we interact with. And these microplastics, and you can see them here, the term for these are nurdles. These become part of sand, they become part of soil. In very, very small particles, they're becoming part of us. And so, again, we need to understand that these impacts, our activities, our decisions of what to make and what not to make, are beginning to impact us at levels that are oceanic to microscopic. All right, so what this really gets us to is then this idea of the biosphere as a model. And what I want to focus on is that concept. When we look at a normal model, if you will, or we can take and simplify this, what we see is that systems have producers, that is the plant material, captures sunlight, turns it into biomass. That biomass is eaten by an herbivore. Herbivore is eaten by a carnivore. But then ultimately, the carnivore both produces waste and it dies. And ultimately, that is recycled into the soil, which becomes the minerals for the plants, and the system continues to run without, in a sense, losing that sustainability. Nothing is, in a sense, lost or gained, and that there is an equilibrium between the population of plants to herbivores to carnivores. And when that system gets out of whack, there are consequences. In the human construct, what we see is a way of understanding human impacts or their deviation from sustainability based on this very simple equation. Again, this is not a true algebraic equation. It is, if we will, a model equation. And so what we have here is I is impact. And so again, for your notes, make sure I is the human impact on our environment. What we know is that our impact is a function of the population in an area. That is, the larger, all other things being equal, people eat and produce waste. And so the more people that there are, the more consumption will occur and the more waste is produced. What we also know, though, is that as a level of affluence of a population, again, given a constant population, population A and B both have 1,000 people in them, the population that is more affluent will tend to a level consume more. There is a tendency that higher levels of affluence produce higher consumption, but only to a level. Once that population reaches a certain level of affluence, its actual impact begins to decline in some areas. And then lastly, there is the issue of technology. And so if we hold the population and affluence constant, differences in technology can affect how that population impacts an environment. That is, again, at a certain level, very low technological level, the population's impact is relatively low. At an intermediate level of technology, the impact can go up quite a bit. And then what appears to happen is that as technology improves to a certain level, there is a leveling off, or in some cases, a slight decline in the impact. But all of these things interact. So as we move forward, we're going to look at this equation and we're going to look at how humans impact the environment in terms of the biosphere, the hydrosphere, and the atmosphere. So we'll see you in the next lectures.